The techniques that we are developing are becoming so sophisticated and scalable that it's really become the only viable method to detect increasingly sophisticated and subtle attacks when the data volumes and velocities are so huge. So think about nation-state attacks where you have very advanced adversaries that are using uncommon tools that won't be on any sort of blacklist.
Welcome to the Reimagining Cyber podcast, where we share short and to the point perspectives on the cyber landscape. It's all about engaging yet casual conversations on what organizations are doing to reimagine their cyber programs while ensuring their business objectives are top priority. With my co-host, Stan Wisseman, Head of Security Strategist, I'm Rob Borrego, Chief Security Strategist, and this is Reimagining Cyber. So Stan, who do we have joining us for this episode?
Well, Rob, today we're going to be talking about artificial intelligence, and I can't think of anybody I'd rather have this discussion with than Stephan Jou. And Stephan is the CTO of Security Analytics at OpenText Cybersecurity, and he leads various analytics-related initiatives for us. Previous to OpenText, Stephan was the CTO of Interset at Micro Focus, a leading-edge cybersecurity and Incutel portfolio company that uses machine learning and behavior analytics. He was also at IBM and Cognos, where he led the development of 10 products in the areas of cloud computing, visualization, data mining, and neural networks. Stephan, it's great to have you on the episode with us today to help us better understand what's going on in this market. Do you have anything else that you'd like to add about your background first before we get started?
I guess the only thing I'd add is in the past 5 years or so, I've become increasingly interested in the ethical and responsible application of AI. You know, pure AI is kind of like pure math. It's neutral. It doesn't have an angle to it, but applied AI is a different story. So all of a sudden you have to think about the implications of your AI product, the data that you're using, and whether your AI product can be weaponized or misled. And so I've started thinking a lot about ethical and responsible AI. I've been blogging about it, writing about it, and I was honored to be an invited participant to the 2018 G7 Multi-Stakeholder Conference on AI, and I was consulted by the Privacy Commissioner of Canada on the regulation of AI for data policy back in 2020, just before everything shut down for COVID. So this is a fond memory, but it was also prescient.
That's good. And you also did a lot of work tracking the COVID virus, right? As far as using some AI technology for that.
Right. That's a fantastic example of AI for good. So using analytics to track the spread of COVID, starting with Canada and some of the regions inside Canada, but then eventually expanding our models to track global spread of COVID. That was a fun project that we sort of did over a couple of weekends because the team and I felt that we want to sort of give something back to the world.
Yeah, I remember that. So ChatGPT is the topic of du jour, right? I mean, it's
of course
taking the media by storm, and you know, it's kind of cool seeing how different users are posting how they are getting these results from, whether it be directly from ChatGPT or using some of the tools like like Bing. Microsoft invested in OpenAI, and I think it's around $10 billion, and they plan to use it in Bing and other tools, and that seems to have spawned some of the other AI players that we think of it being, you know, early adopters of AI, like Google, to even accelerate some of their offerings to market. You're the expert. You know, what is, you know, going on as far as these generative AI tools, and what's all the fuss about?
It's so funny. I mean, you call me the AI expert, and ChatGPT, I sort of both love it and hate it. I love it because it gave people like me so much attention, and I hate it because it sort of highlighted some areas of potential sort of risk, I guess, associated with AI that people are only starting to realize. And at the same time, it's also sort of being credited with AI powers that aren't as realistic as I think people want it to be. That's a ChatGPT. I think we can all agree it's pretty amazing. It is officially the fastest growing internet service ever. I believe it got over 1 million users in 5 days, 100 million users in 2 months. That's faster than Twitter, faster than Facebook, faster than anything else we've ever seen before.
Right.
So I think it's in some ways, like I said, it's kind of nothing new. GPT-3, which is the engine underneath ChatGPT, was released in 2020. And it more or less had the same capabilities in generating text and doing what's called few-shot learning. But ChatGPT, what they added, which is new, which was very clever, is the chat interface, right? So by learning from human conversations like movie scripts, all of a sudden you didn't need to be a data science or a programmer to use it. So that was the case with GPT-3. So the same engine, you kind of needed to know how to use the API to use it. You kind of need to be a bit of a data scientist. There was a playground web UI, but it was still pretty geeky. There's these knobs and levers that most people wouldn't understand. But by basically removing the barrier of entry to use this very powerful pre-trained large language model to generate whatever you want by just talking to it, that kind of got everyone's attention. So suddenly everyone became an AI expert, right? They're all sort of talking about all the things that AI could do, whereas I've been talking about it for years and years. So that's why I kind of smile a little bit when I look at all those stories on the news. But yeah, certainly worth fussing over, right? It sort of made powerful AI incredibly accessible.
That's for sure. I think, well, that's the key though, right? As you said, we talked about this before with you, and it's been around for a little bit, but basically all of a sudden here comes this interface and it unlocks kind of the access for people to start kind of digging in and seeing what it's all about. When you think about the value of AI and how it can help different industries, and specifically, obviously, cybersecurity, right? We've seen it help in different types of capabilities, detection and response as an example, driving better efficiency. What are some of the things that you're seeing, maybe even beyond detection and response capabilities now, but even coming down the path? What's exciting you relative to the cybersecurity applications of AI?
Yeah, that's a great question. Two examples I think come to mind. One is sort of similar to the example that you gave. We do have a lot of AI that we've been developing in the labs for what's now called user entity behavior analytics. So that's my bread and butter. So essentially using time series anomaly detection to kind of learn normal behavioral patterns of users, machines, processes, networks, devices, and so on, in order to be able to detect and quantify abnormal behaviors that may be indicative of some sort of threat. And the current state of the art is actually pretty good. It's pretty good at detecting kind of, I'll call it naive insider threat and, just, standard sort of script kiddie type activities. But what I'm really excited about is the techniques that we are developing are becoming so sophisticated and scalable that it's really become the only viable method to detect increasingly sophisticated and subtle attacks when the data volumes and velocities are so huge. So think about nation state attacks where you have very advanced adversaries that are using uncommon tools that won't be on any sort of blacklist to be able to perform their acts. So the most recent example I can think of is someone that sort of tried to exfiltrate data intentionally, but didn't use any of the standard sort of file copy commands. He just used disk partitioning tools to be able to sort of mass clone the entire content. Now that's not a tool that would typically show up in any sort of rule. So you can only detect that through anomaly detection. And in terms of the scale, think IoT scales, where we have like nation state attacks on power grids, right? There's so much data that's impractical to have a single rule set that can encompass all the possible attack vectors. You really need AI that can sort of scale and understand each device in your IoT grid sort of individually and be able to get at these really subtle patterns that would otherwise be lost in all the volume. The second example is something a little bit closer to some of the technologies that we see in ChatGPT, where you're using something called a large language model, which really understands how to read stuff, right? So ChatGPT has learned how to read and speak human language. And then we also have language models, like computer language models, that learn how to read and write source code. So think about the Codex model that's underneath Copilot, which is the GitHub extension that allows you to sort of generate code from a comment. So using that same type of AI to get a deeper understanding of source code vulnerabilities, patching, and complex SBOMs, so the software bill of materials, that really requires someone like a programmer or an AI that can think like a programmer to be able to sort of read source code. So that is, I think, something I'm very much looking forward to, using these technologies that can understand code and code patterns and how code gets assembled together and built into a product in a human-like way to be able to sort of detect software vulnerabilities without having to rely on traditional pattern matching techniques. So that's a fascinating area of development and research that's going on right now in our labs.
Well, I can imagine a lot of companies or employees at companies would be interested in experimenting and seeing what they can do with those different aspects of generating code for different use cases. And I guess my going back to your comment at the beginning of ethical behavior of AIs, but also just proper use. Are there concerns about IP ownership or any kind of concerns about sharing of confidential information with these different tools that companies should factor into their policies, and what other steps should they potentially take to control risks with employees leveraging these technologies in ways that perhaps the company doesn't even know they're doing?
Yeah, that's a tricky one as well. A lot of these most powerful models, they are exclusively cloud-based. And it's because these models are so big, you can't download them and run them on your notebook. I remember GPT-2 was small enough that I could download it and run it on my notebook. But these large language models, part of the secret power is they've read so much stuff and they have so many parameters that they seem to have developed these emergent properties that make them very, very powerful. But that same largeness makes it impractical to run in anything but a cloud. So what that means is that if you're using certain models like the GPT-3 model that's underneath ChatGPT, if you're using those APIs, you are inevitably going to a cloud service. So that means whatever data you're sending to be analyzed, whatever prompts you're providing to train or fine tune your model, it's being sent to essentially a third party. And the way confidential customer information is handled, for example, if that was something that you were concerned about your employees potentially uploading to the cloud, it really varies from company to company, and it's only enforced basically by policy. There's no easy technical solution to prevent confidential data to be sort of uploaded, because the model can't tell the difference between real confidential data versus fabricated confidential data, essentially. And so really, it's the onus, unfortunately, is on the company to sort of understand the technology that their employees might be using, the policies around it, whether those policies are being enforced or whether it's something that can even be enforced. So that leaves the companies in kind of like a tricky place. They'll essentially be forced to review the AI policies for applications, and vendors should be hopefully encouraged, if not forced by regulation, to disclose those AI policies. So that includes things like how they train the model, where the data comes from, how uploaded data might be reused, whether there's bleed from one tenant to the other. I guess the good news is this is a very comfortable position because it's what vendors and companies should be doing today for data privacy, right? So GDPR brought forth similar regulations where we had to sort of disclose how data is being used. That said, there are some alternatives. So you can look at some of these offline models. So some models are small enough that you can download. Some of these things can be sort of reproduced on a smaller scale inside the lab. I'm a big fan of Stable Diffusion, for example, the image generation technology that is similar to what's in DALL-E, except instead of consuming it as an cloud-hosted API, you can just download it running on your laptop. You can air gap it, and you can sort of reassure yourself that nothing's being sent outside. So there are alternatives to a lot of these more impressive technologies as well.
So Stephan, let's kind of delve a little bit deeper into the data side of it. Right. And you kind of talked about it in a bit, and you said fabricated data. When we look at AI, right, it truly relies on good data sets. And if you think about, one of the attack scenarios that we're seeing out there is AI poisoning. So as data is being kind of, captured, there's this data set that sits out there. The attacker is basically trying to get in there and maybe modify the data, inject their own doctor data set into that model. And obviously that can lead towards the AI algorithms kind of going in the wrong direction, right? Incorrect results, biased results, and so on. What are the things that are out there that you're seeing that can help alleviate that type of concern?
Yeah, that's an area of active research, actually. So I don't have a perfect answer for you, but I can sort of give you directionally what people are thinking about. And you're exactly right, Rob. I mean, the way machine learning works is it needs to learn from something, right? So without data, there's no model to be built. And of course, as you might expect, garbage in, garbage out. Right? So if you give it bad data, then you get bad results. Now, this happens normally, I guess, just as part of the way a model like GPT-3 learns, right? A lot of these large language models read from the internet, right? And as we all know, stuff on the internet is not exactly high quality, right? Because the internet is made up of humans, and not all humans are perfect. So why does Codex, the code writing model, sometimes generate bad or buggy code? Well, it's because it's learned from humans that sometimes write bad or buggy code. The other problem with a data source like the internet is it's not filled uniformly, right? There's a demographic skew to content on the internet that's largely, based on English-speaking countries, is largely male. There's much more male content there. So there's overrepresentation, underrepresentation from different social demographic groups. And that leads to bias. Now, the good news, I guess, is there are sort of technical and mathematical techniques to detect and quantify bias and try and correct for it. So that's the good news. So an area of active research for everyone in the AI community is both the detection and the correction of bias. And that's better than what happened in the past, right? In the past, I think a lot of the challenges of human society and prejudices were just kind of not really recognized or talked about. But here, because this is essentially math, we also have mathematical techniques that people are developing and actively working on to try and detect these things. Now, that's just sort of unintentional bias and problems. So you talk specifically about AI poisoning, and that's very interesting. AI poisoning is much more intentional, right? So this is where the adversary intentionally inserts bad data in order to trick the model. There are all kinds of sort of sophisticated examples of AI poisoning that vary from algorithm to algorithm, but I'll give you my favorite sort of simple example. Let's suppose you have a very simple system that is trying to look for unusual amounts of files copied to a USB key. So you can imagine how such a system might be able to sort of learn over time, with enough data from you, how much, specifically Rob uses his USB key. And it might say, okay, on average, he copies files for 5 files a day. So if you are trying to intentionally poison that model, you can imagine how the adversary might start off by copying 10 files a day, and maybe 20 and 30. And essentially, he's poisoning the model by increasing the threshold that the attacker believes is sort of built into the model. Mm-hmm. So the general idea is, if you know the algorithm and you know that that's the only algorithm at play, you can apply these sort of mathematical tricks in order to sort of poison the model. The good news is this is very difficult to do in practice, quite honestly. A lot of the papers that we see on AI poisoning, they're much more theoretical than they are practical, right? So, if you're employing this type of algorithm, then here's something that we fabricated in the model that can defeat this algorithm. If you're using a cluster algorithm, here's an anti-clustering algorithm that will make you misclassify. But in actual sort of cybersecurity algorithms, in actual cybersecurity products, it's a lot more difficult to do this in practice. So as an example, so take what I just talked about for tracking exfiltration using USB key. In a typical cybersecurity application that has models like this to detect unusual behavior, such as the one that we have at OpenText, you don't just have a single model that is looking at the number of files that you're copying to a USB key. You have hundreds of models that are all running in parallel simultaneously, looking for different vectors of unusual behavior. So to evade detection completely, the attacker would essentially have to poison all these models simultaneously. So, maybe you think that you're tracking the file sizes copied to a USB key exclusively, but did you also know that we might be looking at the processes that you're running? Did you also know that we might be tracking the types of IP addresses that you're using to log in? Did you know that we're also tracking the timing between keystroke behaviors, for example? So there's, the fact that there's hundreds of these means that in order to sort of completely evade detection, you would have to launch a simultaneous AI poisoning that would be really, really impractical to do in real life.
So how does that differ from an attack technique like, prompt injection?
They're technically different techniques, although they do share a similar goal. So both prompt injection and AI poisoning is intentionally malicious insertion of some sort of data to make the system do something harmful, right? So we need to take a step back and talk about prompt engineering specifically. So prompts are the text that you would type into the text box to tell ChatGPT to do something, right? So those are called prompts. And because of systems like ChatGPT, we now have this entire sort of area called prompt engineering, where there are sort of essentially tips and techniques to be able to sort of get the chatbot system to do what you want it to do. So here's a certain phrasing that you can use to sort of make your GPT system talk like a pirate, or here's a series of prompts in which you can sort of get the GPT system to drop the filters that it normally has and make it, swear more, right? And so there are all these sort of things like that you can do to sort of make unintended behavior happen. So prompt injection is essentially just sending to the ChatGPT system or equivalent prompts without the knowledge of the user that is also interacting with that chat system. So the examples are pretty theoretical, but they have shown that you could do something like embed the Bing chat, which uses a similar chat system as ChatGPT from OpenAI. You can embed Bing chat into a website, but you pre-fed it these prompts so that when the user subsequently uses that chat system, it's been sort of guided already to give malicious answers or to try and steal credit card information or to talk about something that it shouldn't really be talked about.
So Stephan, I want to go back to something you brought up earlier. There's a couple things in this. So one is, we all know that, the kind of craze around ChatGPT exploded just at the turn of the new year. And so, as you said, right, over 100 million people jumping in, like, what's this thing all about? Well, as they're engaging with the platform, they're maybe supplying some of their own personal information as the type of questions that they're trying to ask and engage with. So on that front, right, now it's capturing all this personal information that can maybe potentially attribute to you as an individual, one. And then the other thing we talked about a little bit earlier, you mentioned was, each organization has to think about and should be applying, kind of their own policies or guardrails and how that type of information will be kind of contained, shared, and whatnot for AI purposes. But there's this potential for privacy coming behind it and regulation specifically, right? So connecting those two things together, there's personal data that's getting captured. What are the concerns in that personal data per se to date? And then what are your viewpoints and what are you seeing around regulation? There's been some chatter, but obviously it's still very early on.
Yeah, there's definitely a lot going on there. So let's start with personal data and how that's handled. I guess I'll tell you a story first. When I first used ChatGPT, the first thing I did was I asked it a question about a sort of health condition that my wife was going through. And so I sort of went in and I said, my wife suffers from this, and what are the symptoms and what can I do about it? And the first thing ChatGPT did, which was amazing, was said, "I'm sorry to hear about your wife." And so sort of actually apologized and then sort of gave the answer. And I thought that was just a fantastic example of kind of the emergent human-like behaviors that
the emotion, right?
Yeah. It was actually really, really interesting. Anyway, so what did ChatGPT do with the personal data that I uploaded? So I now know that it sort of recorded some of that information and it went in, according to OpenAI, to possibly be used for model improvement, right? And that's known. But to be honest, it's probably no different than doing searches in Google today versus doing my searches in DuckDuckGo, right? So just like if I entered information asking about the treatment for condition X in Google, I know that Google is storing some of that information, at least at a metadata level. But I know if I enter that same search query into DuckDuckGo, DuckDuckGo is not, right? So different tools handle personal data differently. OpenAI's policy do make it clear that they store and use all your prompts, but the same is not true of other systems. So for example, if you go to Perplexity AI, you get a lot of the same benefit as Bing Chat and ChatGPT, but without the policies that are related to storing that personal data, right? There essentially is no history there. So unfortunately, it goes back to sort of understanding the policies of the company that is behind the system that you're interacting with. And to make it even trickier, these policies change all the time.
Well, Stephan, thanks again for coming on. It will not be the last time we talk about this topic, and I'm sure I'll have you back on because this is just moving very quickly, which is great to see. And again, the passion that you've exerted on the topic, and we know your background, obviously, this will continue to evolve, and we're going to have much more conversation on the topic relative to, of course, the implications around cybersecurity. So thanks again, Stephan.
Absolutely. Anytime.
Hey, thanks, Stephan.
Thanks for listening to the Reimagining Cyber podcast. We hope you enjoyed this episode. If you would like to have us cover a specific topic of interest, feel free to reach out to us, and you can find out how in the show notes.
Hello, producer Ben here, and before you move on to another podcast on your playlist, I have a suggestion for you. Why not stay here and listen to even more from Rob and Stan? You just listened to episode 51 of Reimagining Cyber, which means there are plenty of others for you to devour. For example, back in episode 8, the guy spoke to Jeremy Epstein, lead program officer with the National Science Foundation. He shared the importance of sociotechnics and sociotechnical research and how it can be used to improve one's cybersecurity landscape.
There are just cybersecurity challenges everywhere, whether it's your coffee pot or your car. All of these are sociotechnical problems. They're not just purely scientific problems. They cut across computer science and social sciences like criminology, sociology, geriatrics, et cetera, et cetera. There are many different areas, and it's pretty much hard to find anything that isn't affected by cybersecurity.
Jeremy Epstein there from the National Science Foundation. Finally then, you know the drill. We'd love you to listen, rate, review, subscribe, follow, and share with your friends and other folks in the cyber industry. Thanks so much for listening.